In this and the following module, we will work on a new experimental project to review a variety of structural and construction concepts within ArchiCAD. This first module will focus only on structural concepts, where we will explore how to push the limits of the column and the beam tools, along with the integration of various objects in order to provide solutions for the foundations, columns, and beams in the development of our structure. Feel free to pause and revisit the videos as many times as needed, and don't forget that each lesson includes resources and downloadable materials to support your learning process. With that said, let's get started. Alright, so let's start off a completely new topic and let's talk a little bit about which concepts and topics we're going to cover for this particular section. In this case, we're going to start covering everything about structures and constructive systems in ArchiCAD. Now, I want to clarify, I'm not going to cover concepts about how you can analyze or calculate the structure in ArchiCAD. This is something really specialized that engineers who use ArchiCAD might want to seek for. In this case, we will only focus on the modeling part, on how you can use diverse types of tools to simulate diverse types of constructive systems, structural elements, foundations, and more elements. Okay, so pretty much this is more about on how you can solve and model out different types of elements and simulate them within ArchiCAD. Now, I want to clarify that in an international scope, it's really hard to document, to guess which type of constructive system every country has. So what I'm going to do is I'll use the same example which I used for the Spanish version of ArchiCAD. This is something that I want to make it clear. In Mexico, we usually use all of these types of constructive systems and even more constructive systems. But make sure to, if you're, for example, from China, go ahead, use your own constructive system and your own elements. If you're from United States, from Europe, feel free to adapt this however you want. The most important thing here is that you understand how you can integrate different types of tools to solve pretty much the most common types of case scenarios of structural and constructive systems within ArchiCAD. Okay, for example, the standardized codes we have for the beams, these ones are for the Mexican region, but if you're from China, Europe, United States, South America, feel free to use your own standardized elements. Okay, now I want to clarify that I'm going to explain this topic with this experimental project in two parts. For this first section, we will only focus on modeling out the foundation, the isolated type of footing, the corner type of footing, the continuous type of footing we got over here, and also the tie beams that we require, which are connecting the pilasters and the footings among them. We also will model out the columns, we'll model out the primary beams, and also we will model the secondary beams. And this is going to happen using standardized type of measurements, standardized types of profiles, something I'm going to explain in a little bit how you can import your own standardized elements. Okay, so for this section we will only focus on columns, primary beams, secondary beams, and the foundation. And in the next section, which is the next part of the same topic, now we will focus on modeling out the different constructive systems, the steel decking, the waffle type of slab, we got prefabricated elements, we got hollow block and beam type of slab, we got different type, specific and different types of trusses. I'm going to explain to you how you can create your own custom trusses, how you can position the purlins, which are these small beams over here, the horizontal elements that are going over here, and finally how you can also simulate a metal type of sheeting which is positioned on your different purlins. Okay, we also have a three-dimensional type of structure going on over here. Well, this is something we're going to focus on the next part of the constructive system. Okay, and also we're going to do everything with really a not so real type of example, not so real type of project, but a really good one for experimental purposes. So yeah, we might have a really messy type of structure going on over here, but definitely this is one of the best examples to cover diverse type of structures, because in real case scenarios, you can always, for example, solve the whole project using just the waffle structures. But the idea here is to cover not one, not two, but many diverse types of techniques and methods that will always sum to your learning process. I'll include this brochure. Make sure to check out the experimental project and make sure to create a completely new ArchiCAD project from zero. So in the next lesson, we start modeling and checking out the different tools and techniques in order to solve the base structure for the project. Alright, so before we start modeling the experimental project for structures and constructive systems, first things first, we need to specify the level that we're going to use on the project. As you can notice, we got the ground floor level over here, which is 0, and also on the negative side, below this level, we got a foundation level, which is minus 1.50 meters, okay? Then we got the first level on above 3 meters, and then the second level, which is going to be positioned at 6 meters and 9 meters. So first things first, let's start off by defining these different levels, okay? Let's go over here. You can, don't forget, you can simply press Ctrl 7 if you want to open this window a little bit faster, or right click it and start settings, okay? So we got the ground floor. Let's specify, let's create another level over here, which is going to be level 1. Let's create the next one, level 2. One more, which is going to be level 3. And also, don't forget, you need the foundation level. Let's press the insert below button over here. And let's create as foundation level, which is going to be positioned at minus 1500 millimeters or 1.50 meters. Okay, let's press OK. So we got the levels. Now in the next step, I'm just going to specify the working units, because you know me well. I prefer to work on meters, but feel free to use any type of working unit you wish to use, okay? Just going to go with meters, 2 decimal places, and to be honest, everything's looking good. So with this, we can say we got the preliminary stuff ready for the project. Just going to delete maybe these elevation views, delete the viewpoint, and delete anyway. Okay, so having said this, now let's go to the column tool, and let's start covering and talking a little bit about how these different settings will work in depth, and also something real important and the focus over here, how you can create a segmented type of column and how you can specify the profile or the specific type of profile you want for your column. So pretty sure that in the previous lessons of this present course we already specified these different settings, but let's simply review them once again. Pretty much over here you got the width and the depth for the column. You can also link them so everything stays completely as a square, or if you want a rectangular type of profile, you can switch this and specify each type of profile however you want. Now in the positioning, you will notice that this is quite familiar with the wall tool. You can simply specify from which level your column will start and at which level the column will end. And also you got the different offsets from the level you got below and the level you got above, or the top link or the home story. Then you got the angle, whether you want to generate a column which is at an angle. You can specify it whether it's vertical or in this case whether it's slanted. And of course, you can also specify the angle for your slant. So if you notice over here, the column is going to be now slanted instead of being completely vertical. Also, you can specify this in the 3D view, which is quite easy, but for this case, I'm just going to keep it simple, keep it vertical. Now, I'm not sure if I already covered this concept over here, but this is how the column will integrate with your different finishes, with your different composites, whether you're working with composite walls with multiple layers of finishes. Pretty much the first icon will specify if the column is not going to be wrapped with the same finish you use within your wall. And the second icon over here will make your column wrapped in the different finishes you have within your composite. So let's say I'm going to press OK, just going to position this column over here. Let's activate, for example, the wall tool and maybe use some type of composite type of wall over here. Just going to create maybe something basic. And let's take this column, just going to rotate it and position it inside over here. So as you can clearly see, since my column by default has the wrapped option active, you can notice how the different layers of finishes will wrap around this column. But let's say I'll take this column over here and deactivate the option. If I press OK, you will notice that the finishes will just be completely cut off. We can even take this column, maybe bring it to the front. Okay, this is not going to work. Don't forget that this happens because we are using a material that has less priority than the material for the block. Okay, so the block has probably more priority than the material for the column. But if I take this column and maybe switch it to, let's say something as steel, which has a lot of priority, you can now see that the column is cutting off the wall. Okay, so pretty much this is how the wrapping method works. You can use either of these two options. Then you have how you want to specify the edge or the end cuts for your column. You can specify this to be completely slanted or maybe at some type of custom angle. Or if you create a slanted type of column, you will notice that now these two icons will be active. So just keep this small detail in mind. If you have a completely vertical type of column, this is going to be deactivated. Let's say I activate this once again, you will notice that these two are deactivated. But if I create a slanted type of column and if you activate the borders over here, you can clearly see how the angle or the cuts of the column are completely switched, are completely vertical. If I set the column to be at 45 degrees, the cut over here is still vertical and this one is vertical. But if let's say we make it maybe some type of custom angle, maybe some type of 45 degrees, you can notice how the cut is being created at an angle. So pretty much you can mess around with these options to create your perfect column. The best part of this is that you can also specify and modify this completely in 3D. So let's say we got the column over here. And if you click on one of the nodes, if I remember well, we got this option over here, the rotate join angle. So you can specify the same option completely graphically with the possibility to modify the angle in 3D. So this is quite useful, something real nice that was introduced, if I remember well, in ArchiCAD 25. So you can also mess around with this option. We also got the different reference axes of the car. Now, this option is really useful and especially useful when we start creating the isolated type of footing and when we create the cornered type of isolated footing. With this small option, we can specify where the dintel, if I remember was the word in English, is positioned on the footing. Okay, so you can specify for this small part to be positioned at the center, at one of the corners, and everything is done thanks to this parameter. So pretty much you can mess around with this option. This is something we're going to go back in a little bit. And also you got the axis rotation, which is just how you want to rotate your column at an horizontal angle. Okay, if I set this to be 0 and press OK, you'll notice that the column now is positioned completely perpendicular to the camera. But if I set this to be 45 degrees, you'll notice that it's going to rotate the column at an horizontal or X and Y plane. So pretty much these are the main parameters that we can find on the column tab. Just take a few minutes, mess around a little bit with these different types of parameters, see how they work. And in the next lesson, we can continue covering the different parameters we got for the segment. Alright, so having covered the general parameters for the column, let's continue with the segment. Now, in the segment, you'll notice that it's going to be pretty much the same as the very beginning. You can specify the depth and the width for the column profile, or you can also leave it completely unmodified. Now you got a really important option over here, whether you want the column to have some type of constant profile, okay, or if you want to segment the column in multiple parts. So let's say, for example, you want to specify some type of prefabricated union at the top of the column, and then you want another type of part, something like this. It is completely possible to create two different segments. Or let's say you want to create, which is something we're going to use for this example, an isolated type of footing using the column tool. So it's also completely possible. You can segment this in 3 different ways, where you have the base for the footing, you have the slope, and you have the pilaster. So you can divide the column in different parts, and you can edit each of the different parts until you get the desired result. For this example, how about we specify the end cuts to be completely horizontal, so it doesn't mess up the parameters for the example. And how about we make a small example just for this case, which is going to be the isolated footing. Okay, so for this case, what we can do is start off specifying whether this is a single segment, multi-segment. Since in the isolated footing we have something like this, which is going to be composed of the base, okay, then we have a small slope for the footing, which is something like this. Just going to draw it in cut section, and then we have the pilaster. We have segment number 1, segment number 2, and segment number 3. So in this case, what we can do is add 2 extra segments, and then we can continue to move on which type of profile you want for this segment. Okay, so as you can notice over here, I'm currently editing the segment on the very bottom. Okay, you can specify which segment you want to edit, just select the segment. For this case, you can specify the type of profile you want to use. You got 3 different options. You can use a completely rectangular type of profile, or if, let's say, maybe you are creating your footing and want to integrate some type of column with the footing in just one go, it's completely possible, and you can create a custom type of segment over here. Or you can even, for example, position a completely custom type of profile where you integrate some type of custom steel type of profile where you have your pilaster, you have the slope, and you have the base for your column. So you can pretty much solve the whole column with the different parts in just one go with just one element. Now, I wouldn't recommend that much doing this, because it's better if we model the column or the steel column by separate, and if we model the footing, the isolated footing, also as a separate element. It's much better on a project. So what we can do for this case is keep it as completely rectangular. Now, moving on, you also have the possibility to specify whether this is going to be a uniform size or it's going to be some type of barrier type of profile where the top has a specific measurement and the bottom has another type of measurement over here. Now, moving on, for this example, what we can do, how about we take the base over here for the isolated footing, and let's say that the base is going to be somewhere around maybe 1.50 meters by 1.50 meters. Now, for the height, this is a really interesting detail over here, because at the very beginning we already specified the links for the height. We specified the column to start on the foundation level and end on the top link. But for this case, what we can do is also specify to be completely unlinked, and then specify the height completely freely with the use of these parameters. So let's see which was the height for the foundation. If I remember well, it was something as 1.50 meters, because the base for this footing has 0.375 meters. Then we have the sloped part, which is also 0.375 meters. And then we have the pilaster, which is going to be 75 centimeters. Okay, so from the very beginning, let's specify the height for the column, which is going to be 1.50 meters. And then now for the segment, this is where things get interesting, because what you can do is you can specify how the height for each of the segments will divide. You can specify, let's say, 50% of the first segment, 50% of the height is going to be destined for the first segment. Then 25% of the second height is going to be destined for the second one, and the last 25% for the third segment. This is where you can control the height for each of the segments, whether you want to specify a completely static type of value expressed in meters, or you can use this in percentage, where you can say, let's say, the base is going to have maybe 1/4 parts of the height is going to be destined for the first segment. Then the second segment will have maybe 1/3 of the full height, and the last segment, ArchiCAD will automatically adjust the height for you. Okay, but for this case, how about we mess around a little bit? Maybe we can set the fixed type of height, set it to be 3.75 or 0.38 for the base. Okay, for the sloped part, we can also specify a fixed type of height and specify it to be 0.375 for the sloped part. And for the last part, well, the fixed height is not going to work. Well, it's going to work, but if you change this value, ArchiCAD will adjust the general height. So my recommendation here is that you just leave it as percentage, as a flexible height, and ArchiCAD will automatically detect the height over here, and the rest of the height is going to be destined for the last part of your column. Okay, so pretty much this is just a matter of messing around with this parameter, but just keep in mind that everything related to the height of each of the segments, you are going to control it with the use of these different parameters. Now, moving on to the different dimensions for the width and the depth, we can start specifying the width and the depth for the base. Over here, everything is ready. And now this is where things will get interesting, because if you remember, we have a sloped type of element over here, which is going to have the base of 1.50 by 1.50, and then it has to end in something as, if I remember well, this was somewhere around, let's see how the foundation floor looks. So yeah, it's going to end in 60 by 60 centimeters. Okay, so for this case, what we can do is, instead of a constant or fixed type of uniform size, we can switch this to something a little bit more tapered. And this is where you can click over here on this small arrow and specify the measurement of the width and the depth for the bottom, and the measurement for the width and the depth of the top part. So let's say it's going to start with 1.50 meters by 1.50, and it's going to end maybe in 0.60 by 0.60. So as you can clearly see over here, you are going to have some type of sloped element which will conform the sloped part for the isolated footing we are trying to achieve. And for the last part, what we can do for this example is maybe set this to be a uniform size once again, and set it to be maybe 0.60 by 0.60. So as you can see, you can mess around with the segment. This is just a matter of practice, of messing around with the different parameters. This is where you're going to specify the measurement for the width and the depth of your segment. And over here, you will specify the measurement for the height. So as always, take just a few minutes, mess around a little bit with these different parameters. You can add as many segments as you want, and also you can remove the segments with this other button. And in the next lesson, we're going to continue covering extra details for the segment part for the column. Alright, and moving on, let's comment a little bit about the extra parameters we are missing over here, and simply finish up with the floor and plan and section parameters. Now, you also have the possibility to specify which type of building material you want to use within your column, whether it's going to be concrete, whether it's going to be some type of insulation, some type of steel. You can specify this material which is going to apply for the whole column. You also have this small button over here whether you want to create some type of covering for your column, or in other words, if you want to add some type of veneer, you can also specify in the same way we already did for the composites. If you remember well, we need to specify whether a layer of the material was going to be the core, finish, other type of element. The same will apply for the veneer over here. So you can also specify whether the veneer is going to work as a core element, as a finish, or another type of element. And also you have the covering or the veneer thickness. You can input the value over here to specify the thickness for this element. Okay, and of course you have two separate materials, one of which is for the column in general, and one of which is going to be specifically talking for the veneer. For this case, how about we deactivate this option? This is just an extra part for aesthetical purposes. Moving on, we also can specify the we also can override the texture or the surface you can use within your column, whether it's going to be some type of other element. You only have two different types of surface, one of which is for the ends and one of which is for the extrusion part. So in general, these are the parameters you can use for your column. As you can see, something interesting over here. Just keep in mind that you can also apply different types of surface or textures for each of the segments. So let's say the first segment is going to be maybe some type of yellow. The second segment, you can specify this to be maybe some type of blue or some type of other type of surface. And the third segment can have another type of surface. So just keep in mind that this function over here also applies for each of the segments independently. And moving on, finally, we also have the floor plan and section group over here, which in general has the different parameters that will affect how your column will document in the floor plan display. Okay, in first place, I'm going to be honest with you, just going to make sure that the axis rotation is set to 0. Just going to set this over here. Let's go back to floor plan and section. And over here, you can specify how you want to display the column, in which stories it's going to display, whether it's in all the relevant stories, in all the stories, maybe just in the home story. You can set it to whichever type of display you want to use. Okay. Then you also have the possibility to display this as a projected element with some type of overhead, especially if your column has some type of slant or angle, or if you want to display your footing or column as a complete element, you can always set it to simply outline. So as you can see right over here, the projection for the footing is going to switch. Okay. You have the different parameters for the cut surface. I'm going to be honest with you, this is literally almost the same as with the wall parameters. So if you already have the idea of how you can specify different parameters for the display of the wall, this is really easy for you. Okay. You also have the different parameters for the outlines, and something extra that we also need to comment is that you have the possibility to include the floor plan symbol. Okay, right over here you will notice we have this small crosshair over here, which is going to mark the center for the column or the pilaster or your element. Okay, and you can also configure how you want to display this type of crosshair, whether it's going to be completely plain, or in other words, it's going to be disabled, or you can specify whether it's going to be some type of slash. Or maybe let's say you are trying to create a column which is completely hollow on the inside. This is completely earth. So in architectural plans, we need to specify with an X that the columns that we are using are hollow. And this option is especially useful if you want to mark if the column is hollow without the need to manually draw just an X. Okay, so this is one of the options that I have used in the past more commonly, but I leave this decision up to you. And finally, you can also, if you use the crosshair, you get extra parameters, for example, the distance from center, the length of outside of the column. If you use something else, well, you will only get the parameter for the column crossline pen, which is basically the pen you want to use with your column. Now you also have an extra group for the column, which is meant for structural engineers. I'm going to be completely honest with you. As an architect, I have definitely no experience with this group. Keep in mind that this is extra useful if you are an engineer and if you are planning to do basic structural analysis within ArchiCAD, which is completely possible with really specialized options for structural analysis. So this apartment or group over here is meant for more specialized roles. This is something I rather now cover in this section, which is more focused on the simulation of structural and constructive elements with the different tools. Okay, so as always, take as much time as you need. You can mess around with the parameters for the column, mess around a little bit. You can also, for example, go to column. Don't forget you can always click on favorites. And if you notice over here, you got a bunch of examples that you can take in order to analyze how you can use different options to simulate different types of elements. For example, we got some interesting case over here, which has this prefabricated type of union or this prefabricated type of element, which is clearly done with the segment option. So if you notice over here, we have a column composed of 4 different segments. The first one is basic, the second one will have some type of tapered size, but the tapered size, as you can see, has different widths and different depths. Okay, then we got another segment which is also rectangular, and the final segment which is a square. Okay, so this one is composed of 4 segments. If we take another example, for example this one, let's double click it, let's analyze how it behaves, and if you notice, this is pretty much the same that we already did. Instead of starting from below, it starts from above, or in other words, it's completely reversed. So as always, take as much time as you need. Make sure to mess around, play around with the different parameters. And having said this, we can now put the column to the practice and start little by little the experimental project meant for this section. Alright, so having explained the different parameters for the column, let's start the project. For this case, I'm just going to select all the different 3D doodles I have over here. Maybe pick up the parameters for the column so they are saved within the column tool. And now let's delete everything. Let's go to the ground floor. And how about we maybe, just to have some type of even the most basic reference, how about we take a little bit of reference lines over here. If I remember, everything was separated 6 by 6 by 6. So what I'm going to do is simply just a basic grid done with basic guidelines starting from the origin. Okay, I'm just going to take this line, offset this by 6 meters, input another type of guideline over here, take this line over here, offset this one 6 meters, input another one, okay, once again offset this one but by 12 meters, and finally generate the last reference line. Okay, so how about we use the column tool in order to solve, maybe we can use the column to solve actually this one, and this one. And we can leave this isolated type of footing, so I can explain to you the second method on how you can solve the footing using objects. Okay, so for this case, let's start off once again. Let's go to the column tool. Just going to take a second to maybe fix some type of weird slant going on over here, which is done with the end cuts. I'm just going to reset this as to how it was before. The height, if I remember well, this one was 1.50 meters, and also make sure to set the home story for your footing to be positioned on the foundation level, or in other words, to have a bottom elevation of minus 1.50 meters. Okay, let's jump into segment. I'm pretty sure that we already solved everything we require for the footing, so yeah, it looks quite good. So let's press OK. Now if you simply press left click, continue, because Okay, this happened that it will give us this small warning as a result of the last operations. Elements have been created on another story. This happens because we are trying to create a footing on the foundation level while we are visualizing the ground floor. So just keep in mind that it's still created, it's not going to be visible, but if we go to the foundation level, this is where the column is visible. Okay, so this small detail that also has to be commented. Now let's position, okay, once again, left click, you can position your column. You also have different types of geometry methods. You can position one by 2 clicks, which basically is going to create some type of slanted column. This one is quite useful if you want to create a slanted column or have or specify some type of slant angle. You can also specify this parametrically. Let's say you want to create a column which is slanted at 45 degrees. You can input 45 over here, press enter, and the to method click is going to give you slanted type of column. You can also use the third one, which is rotated, which pretty much will specify the rotation on the XY axis. So as you can see over here, we have created the footing, which is completely rotated. Yeah, it's still vertical. So yeah, pretty much this is how you can rotate the column. For this case, if you want to solve this specific isolated footing with the column method, the only thing you need to do is simply use the first method, left click, and pretty much that's it. That's how you solve the most basic type of footing for your project. Now, if we go back to the project, you will notice that we have a boundary type of footing over here, which is has a line over here and the footing is offset. Okay, and besides the boundary type of footing, we also have a corner type of footing. So this is where things will get interesting, but trust me, this is really easy to fix. The only thing you have to do is activate the parameters for your footing. Let's go back to the column settings over here, and you can simply use the reference axis of the core. For the boundary footing, what you can do is simply set this to be on the center or on the left part of the center. Sorry, my English is not the best. I'm trying, I promise. Let's press OK. And you can simply press left click, and this is how you can create the boundary type of footing. Okay, now for the corner type of footing, you can also set this as simply as click over here, set this to be on the corner, and trust me, that's it. That's the only thing you have to do. You simply need to press left click, and that's how you can create the corner type of footing. So as you can see, the column tool is quite amazing in ArchiCAD because you can create multiple types of footings with just a few clicks. Okay. So for this case, what I'm going to do is I'm going to set the corner footing, maybe, okay, we have some issue over here because we need to select the center over here. Let's take this center, offset this to be positioned here, okay. Let's take the next center, something like this, click, and we position the center over here. If I remember, we also have an extra footing. Yeah, this one is also going to be boundary footing. So let's go back to ArchiCAD. Let's maybe select this one, create an extra copy over here, and maybe switch the reference axis of the core to be on the top part, on the top center part of the column. Let's press OK. Okay, so this one is a little bit messed up. Just going to rotate this once again. I could give you an extra recommendation. Rotating the column is not going to be a good idea because, yeah, as you can see, the reference axis core will respond accordingly to the rotation of the column. If you take the column and if you rotate it, you will notice that the reference axis of the core will behave a little bit weird. So my recommendation here is to keep the column straight and just leave it completely horizontal. Okay, let's simply take the column. Let's make sure that it's set to be centered over here, and with this we can say that we have solved the 4 types of isolated footings that we require for this example. So as always, take a few minutes, mess around with the different parameters, make sure to solve the first footings for your project. And now in the next lesson, what I'm going to do is I'll delete the footing I already positioned with the column. This one over here has to go. And I'm going to explain to you another second method of how you can create different types of foundations within ArchiCAD. Alright, so far we have commented different possibilities we can create with the column tool. But now let's take a moment to comment how you can also solve different types of footing using the object tool, which has, trust me, really amazing objects that we can use for structural and constructive purposes. Okay, so let's go over here to the object libraries and make sure that you click on the building structures library, which is 1.4. And you will notice that you have multiple types of different folders with different types of elements. And the one that we can use if you're planning to create some type of continuous type of footing, you can use the beams folder. All of these objects, you can use them, especially these ones over here, you can use them to also simulate a continuous type of footing. You can also go to columns. As you can see, we also have the possibility to create a precasted or prefabricated type of column with the use of these objects, which are extremely parametric. It's just a matter of messing around with the numbers, with the parameters. So this is also another possibility that you can use instead of the column tool, which was quite useful before ArchiCAD. If I remember well, somewhere around in the version 23, 24 of ArchiCAD, they completely switch how the column works, okay? But the object that we're going to use for this example is this one over here, the precast sleeve found 27 in the foundation folder. So what you can do is right over here, you got the different parameters for the style and dimensions, where you can specify how you want to generate some type of hole, how you want to generate the column shape for your footing. For this case, I'm not going to create the column with a hole, because usually in my region we use anchor bolts or anchors for the column. So this one is completely filled. You can simulate or you can delete, in quotation marks, delete the hole within the foundation. In really easy steps, you can simply set this to be 0 and set this to be also 0. This is where you can specify the dimension of the hole, the width and the depth over here. So we set this to be 0 and 0. When we position the object, you will notice that it's not going to have a hole included within the foundation. But if you include some type of parameter over here, let's say maybe as it was before, 0.30 by 0.30, what's going to happen is you can clearly see it's going to include a hole within your footing. Now, this will depend on your constructive systems within your country, within your region. So feel free to configure this, feel free to adapt this to whichever constructive system you require. Now for my case, I'm going to keep it simple, 0 by 0 for the hole. And this is where, if you are going to set the hole to be 0, you definitely want to modify this parameter, which is the width of the wall, because it's going to specify the pilaster for the footing. If we have a pilaster that measures 0.60 by 0.60, what you have to do is set this value to be 0.30, because ArchiCAD interprets this parameter as the half of the whole pilaster width and depth. So we set this to be 0.30. As you can see, the pilaster over here is going to measure 60 by 60. Okay? So this is how you can set the different parameters to simulate the footing. Now moving on, let's set the base to be 1.50 by 1.50 if I remember well, and the height, if I remember, it was 1.50, somewhere around this. Now the base for the footing, or the thickness of the plate, is going to be 0.375. Then we got the ascent of the plate, or the sloped area, which is also going to be 0.375, and then we got the final measurements for the pilaster. Okay, I'm just going to leave it as it is, press OK. Let's see how this one behaves. Okay, and the total height is 1.50. Okay, the base is 0.38, the sloped area is 0.38. So yeah, pretty much it's perfect for this example. And pretty much that's it, how you can simulate and use these foundation objects in order to simulate another type of footing. You can also mess around with the representation and materials. You got a bunch of parameters you can specify over here. Finally, but not least, you also got the properties and descriptions. But this is something we also cover in a more advanced type of course. You also got prefabricated types of slabs. This is something we're going to comment in a little bit in the upcoming lessons. And if you are looking forward to simulate a continuous type of footing, go ahead and use the beams folder. This is where you can use these two objects in order to simulate a continuous type of footing. I'm just going to finish this process with moving the column, aligning it to the center. And this is the second way on how you simulate your footing. Now we just have to make sure that this is a little bit elevated over here in the right height. And yeah, pretty much that's it. So as always, take as much time as you need. Check out this object, which is quite easy and practical to use. And in the next lesson, we are going to continue covering different types of details. Alright, and having explained the different alternatives in order to model the isolated footing, the corner footing, let's continue now on to the next type of footing, which is the continuous one or the strip footing. And pretty much what we are going to do is basically what we already did in the previous course, which was the strategic and constructive modeling course. In first place, how about we go over here to options, let's activate the complex profiles, and let's activate the profile manager. Don't forget, this is where we are going to draw the custom profile for the continuous footing. And in this case, as you can notice in ArchiCAD, we already got a bunch of different types of shapes, different types of profiles that we can already use. Don't forget that if you want to create your fully customized type of profile, you can simply click the new button over here. Let's name this as, I'm just going to set 00 so it appears as the first thing on the list, and name it something as continuous or strip footing. Okay. For this case, how about we create a fully new element, not duplicate. You can even duplicate an existing element based off your new shape from a current element. For this case, I'm just going to keep it completely new. Okay. Let's hit the OK button. As always, it's going to take us to another type of window. And for this case, let's go back to the brochure, see if we got some type of reference for the footing over here. Yeah, the height is going to stay the same as with the isolated footing, which is going to be 1.50 meters. And the base is going to be 1.80. The base height is going to be 50 centimeters. And 1 meter is going to be the pilaster, including the sloped area. Okay, so how about we could do this easily. I'm just going to make it a quick screenshot over here, and just base off the screenshot. How about we copy the screenshot? Let's go back to ArchiCAD. Maybe just paste the reference, temporarily speaking. Okay. Don't forget that whichever reference you want to use, you have to scale this down to the real size. So let's select the reference and hit the resize button. Okay, press OK. Left click over here, and this one is going to be 1.80 meters. There we go. Now let's start drawing the profile or the shape we need for the footing. For this case, I'm going to delete the base or the starting shape in the profile manager window. Just going to select this one and hit the delete key. And let's activate once again the fill command over here. Let's go to the fill type, specify over here which fill type, or in other words, the material that is going to represent the continuous footing. Okay. For this case, the material we want for the footing is going to be something as maybe generic structural, or you can go over here to concrete structure. I'm just going to set it to concrete structural. Okay. Now let's start off drawing the shape, maybe activate the polygonal type of geometry method. Let's draw it 1.80. Just going to draw 0.50 over here and maybe 1 meter over here. I'm just going to draw it as a square element, and then I'll simply adjust it. Okay, so I'm just going to insert a knot over here. So as you can see, it's a completely squared type of element. But now what I'm going to do is, if I remember the pilaster, well, that's a good question, which is the width for the pilaster. If I remember well, the columns were somewhere around 40 centimeters. So the pilaster, if I remember well, it was 60 centimeters. Well, it was written all along over here. So just keep in mind 60 centimeters is the width for the pilaster. Let's go back to ArchiCAD. Let's take this edge. I'm going to offset this by, how about we maybe set a line over here. Now don't forget, once you are done with your shape, what you can do is simply select how you want to use this shape, whether it's going to be with the wall, with the beam, maybe a column or some type of object. For this case, we can use this shape with the wall tool and with the beam tool. Okay. What we can do is simply hit the save button over here. You can also create more profiles, rename them, delete them. Well, we got different design layers over here. We got modifiers, we got components settings over here. And finally is uniform profile contours. But these are some settings that I'm not going to cover for this specific lesson, because we already covered this in much more detail in the previous course titled Constructive and Strategic Modeling. Okay, for this case, let's keep it simple. Let's hit the close button. And now what we have to do is simply generate the continuous footing. So we can do it either way. You can use the wall tool or the beam tool. If you want to use the beam tool in the next lesson, in the next 2 or 3 lessons, I'm not sure, I'm going to explain in full detail how you can work with the beam tool. So let's have a little patience for now. But how about we simply use the wall tool? Let's go to the settings, and in the settings, let's jump into geometry and positioning over here, and let's simply activate the complex profile type of structure that we are going to use with the wall tool. Now let's select the continuous footing profile we have generated over here, and now pretty much we are set. Just keep in mind to be careful with to project 0 parameter over here, so it's correctly specified how much depth you need for the footing. Okay, and in the model parameters over here, well, I'm not going to use anything, nor I will define anything over here. Okay, so let's hit the OK button. Let's left click over here. Let's switch the geometry method maybe to a single line, so it's a single footing, and let's left click over here. Now if I remember well, the continuous footing was a little bit offset. It's not exactly on the centers. We have some type of offset going on over here. So we might as well maybe offset the footing a little bit so it integrates a little bit better. I'm just going to offset this maybe to 6.30 or 30 centimeters, and I'll offset this 0.30 plus, so it measures 6.60. Okay. And with this, we can say that, yeah, pretty much we're done with the continuous footing. Okay, so this is one way on how you can solve the continuous footing for your project. Now, in the same manner as it was with the isolated type of footing, you can always, for example, jump into Object Tools, into the building structure folder over here in ArchiCAD, and what you can do is check out the beams folder and go ahead and use one of these 2 different objects. Okay, you can mess around with the parameters over here. The only difference is that this object, if I'm not mistaken, it's not going to allow you to create some type of sloped element over here. It's going to be completely as T-shaped or L-shaped in this case. Okay, maybe the rotation angle, but I'm pretty sure that the rotation angle is meant for the rotation we have on the X on the Z and Y axis. So it's not the rotation of some type of sloped element, it's the rotation in general for the object. So the second option would be to use this option, but the only difference is that it's not going to allow us to modify the sloped area. But pretty much everything else is also possible to modify. So finally, I leave this decision up to you, whether you want to use the complex profile for your continuous footing, or in the same manner as with the isolated one, you can simply use an object and simulate your elements with the object tool. Alright, so moving on, let's continue now covering a little bit, or in depth, the different parameters we have for the beam tool, okay? But before we jump into this, how about we right click on the window, make sure not to select anything, because if you right click it, it's not going to be available. Just right click it, 3D styles, and from the very beginning, how about we set this to be white model. So in this case, we're simply going to appreciate the shape, so we don't worry too much about the material or the appearance for the elements, okay? And now let's activate the beam tool. Let's, as always, jump into the default settings, and let's start commenting a little bit about the different parameters we got within the beam tool, okay? So starting off, you will notice that in the left panel, it's going to behave similarly as it happened with the column tool. So you got different groups, different apartments that you can check out. In general, we're going to start with the beam over here. Don't forget that you also have favorites over here. You can always check out and study the different solutions we got over here. You notice we got some type of precast roof beam. We got precast types of beam. There are many different shapes you can analyze in the favorites, okay? Over here you got the cross-section height and the cross-section width, height and width for the beam. Okay, then you got the elevation, the same as with the column, and then you got specific parameters, whether you want to create a slanted type of beam. You can always set the parameter over here, and if you notice, your beam is now going to behave as a slanted element. Okay, so this is quite useful, because before it was not possible, or it was more troublesome, and now ArchiCAD even allows you to create a curved type of beam, where you can specify the curvature for your beam over here, which is pretty much you can control the arc height, whether you want to simulate some type of specific beam over here. For this case, I'm just going to keep it single. Now, you also got the junction order, which is exactly the same as with the wall tool. Don't forget that with the wall tools, this is something we already covered in the basic beam framework course, where I explained how the junction order behaves. So pretty much in the beam, this is exactly the same. Which beam will intersect in first place, which beam will intersect in second, third, fourth place, okay? If you set this value to something more, like 9, 10, or 11, it's going to have more priority, and it's going to intersect in first place, and the rest will intersect in second place, okay? So pretty much it's the same as with the wall tool. Moving on, we also have the same parameters we already reviewed for the column tool, where you can specify how you want to generate your end cuts and reference axis. For example, you can create a beam that has maybe a cut of 60 degrees. So as you notice over here, we have on one of the borders, it's going to have a slanted edge, okay? You can also set this, for example, if you create a slanted type of beam, let's set this to maybe 45 degrees, it's going to activate these options to create a completely horizontal type of cut. So if you notice, the beam is slanted and the cuts over here are completely horizontal, okay? So for this case, I'm just going to keep it simple, maybe set this to a vertical type of edge or a vertical type of cut. You also got the offset from the axis, because the beam will behave in the same manner as a wall. You will start off, this is something we already covered with the wall tool, but you are going to start off by drawing as a reference line, and then you can specify whether the beam is going to be offset maybe a little bit to the right, or it's going to be offset or positioned to the left, or it's going to be centered. Okay, so pretty much this parameter, the offset from the reference line, will allow you to specify how much you want to offset your beam, your element from this line. And also we got the reference axis. For this case, how about we draw a single beam over here? The reference axis is how this blue line is going to be positioned within the beam. For this case, if you notice, it's set to be on the center top part of the beam, but you can always specify the reference axis to be set on the center of the beam. Now, keep in mind, if you are an engineer who wants to calculate or analyze the structure for your project, this is something that you definitely want to keep an eye out, because for the analysis process that ArchiCAD uses, it will always keep in mind and consider these reference lines. So this is something you have to be on the lookout, especially if you're planning on analyzing the structure with more specialized tools or more specialized functions within ArchiCAD. Now, as I was saying, you have the offset. Let's set this to maybe 0.60, see how it behaves, press OK, and there you have it. You can have the reference line over here and maybe offset the element a little bit to the left, a little bit to the right, however you want to offset. And also you got the axis rotation, which is basically the rotation that is going to happen in the Z and the X plane. Okay, so it's pretty much going to rotate the beam in this direction. We set this to maybe 45 degrees, press OK. There you have it. As you can see, it's going to rotate the beam in the Z-axis plane. So moving on, we also have the segment different options. But before we continue, how about you take a minute, check out and mess around a little bit with these different parameters. And in the next lesson, we can continue covering the segment options we got over here and the other options we got for the beam. Now, if you already know how the segment works for the column tool, in this case, it's going to be really easy for the beam, because this is pretty much exactly the same, but instead of a vertical element, we are working now on an horizontal element. So you also have the multi-segment option over here, or single segment. You can mess around with these two options. If it's the first one, you can specify the length for the beam, or if it's the second one, it's going to give you this table where you can start dividing the beam into different parts. And if you remember, in the column, I explained to you that the height for the column would behave, you can specify how you want it to behave, whether it's going to be with a fixed size or whether it's going to be with a percentage. So over here it's going to be exactly the same, but instead of vertical, now it's horizontal, and over here you can specify the displacement for each of the segments. Okay? So you can set this to maybe be, maybe the first segment is going to be 1/3, the second segment is going to be 1/3 of the full length, and the last segment is going to be also 1/3, something as this, okay? It's just a matter of messing around with these options. You also have the possibility to specify whether the beam is going to be uniform or it's going to be some type of tapered type of beam, or has a different size in the start and a different size for the end. So let's say the beam will start maybe with 0.60. Let's see, we can... Okay, now this one is a little bit messy, because if I remember, the beam is rotated. So I'm just going to set this to be in first place vertical. But right over here you can notice how the beam has a varied section. Okay, or it's a tapered beam. So right over here you can continue messing around with the segment. Let's say for this small example, let's say the beam will start in 0.30 and is going to end maybe in how about it starts with 0.60 and ends in 30. Okay, let's say the second segment is going to continue maybe with also some type of continuous shape, 0.60. And then the final shape maybe will start in 60 and maybe end in 30, something as this, okay? Okay, maybe in an inverted manner. If you have this issue where you messed up and maybe you want to reverse the size, you can always click this button over here. So pretty much it's going to reverse the measurements for the start and the end. If I click this button over here, you can see how the beam will completely reverse where the start and end is positioned. Okay, so let's press OK, and with this you can see we have some type of varied section for the beam. So as always, it's just a matter of messing around, but in this case it's pretty much the same as with the column tool. Okay, now moving on, I'm just going to set it to be a single segment for this case. You can also specify the shape for the profile you want for your beam, whether it's going to be a rectangular profile, a circular one, or in this case what we're going to use for the activities are the specific types of profile. Okay, and right over here you can notice we also have the possibility to create a continuous footing using the beam tool. So in this case you can pretty much draw any type of shape you want for the beam, any type of profile shape you want for the beam, and include it with the profile option over here. Okay, in this case, in the upcoming lessons I'm going to explain to you how you can import standardized type of measurements or standardized types of profiles according to your country, according to your region, with just a few clicks. But this is something we're going to comment in a little bit. For this case I'm going to set it to be basic. You can also override the different surface you got for the beams, whether for the left side, the top surface, right side, bottom surface, and the end surface. So you got 5 different possibilities on how you can override the beam over here. Now moving on, also something interesting to keep in mind. Now this will depend whether you are editing a generated beam, which is already model, which exists in your project, or whether you are just starting to specify the different parameters in the beam tool. If you notice over here, if I select this beam and if I go to the settings, you will notice that the whole group is going to be grayed out and we can't edit these options. Okay, but if I deselect this beam, I once again activate the beam tool and go to the settings, the whole option will be enabled. So before you position any hole within your beam, you can always specify which type of hole you want to create for the beams. Let's say we want to create whichever type of hole we want to position later on. Is going to be a circular shape. You can also specify how you want to display the hole in the floor plan view, whether it's going to be represented with just one line or whether it's going to be a complete contour for the hole. Just going to set it to maybe include the contour. Then you can also specify how big you want the hole within your beam, within your element. For this case, let's say maybe something as 0.10, and also the displacement from the center or the position. You can mess around with these parameters. But pretty much these are the main parameters for the hole, because if you notice we still got the same parameters, but these are for the measurement for the cross section of the beam. Okay. Now the question is how we can actually create a hole once we create the beam. It's not going to automatically create a hole. What you have to do is select the beam, click on the reference line, and over here you will notice you will have the option to insert a hole within your beam. You can once again define which shape you want for your hole, the size, the position, the main shape, and simply press OK. And now you can see that the hole has been created. For some reason it's going to be offset 10 centimeters over here, but no need to worry. If I remember, we can also position the hole later on with this small option. Okay, and also if you have the beam already modeled, you didn't mess around with the parameters for the hole, you have multiple types of options over here. For example, you also insert a hole. You can specify to be a completely squared. Maybe set this to be 0 so it's right on the center. Press OK, and with this you can notice we have a new hole in the beam. Okay, and finally but not least, you also have the floor plan and section options, which is pretty much the same as with all the different elements. Maybe you have an extra parameter over here, which is the type of projection, whether for the overhead, whether you want to display it as a symbolic or projected element, and for the uncut part, whether it's going to be symbolic or project. As always, you have the cut surface, outlines, And also something else to keep in mind is that we have this symbols group. You can specify how you want your beam end lines to behave, whether it's going to be positioned for the both sides, or maybe you have none of the beam ends, which are basically these lines over here. Okay. You can also specify if you want to hide the reference line, or if you want to show it, which type of line you want to use, and which type of pen you want for your lines. And pretty much the rest is the same as with the walls, the slab tools, nothing out of the ordinary. Now, moving on, you also have the structural analytical parameters. If you are planning on creating structural analysis with ArchiCAD, this might interest you as an engineer. For this case and for this section, I'm not going to delve into these concepts for now. And classificational properties, well, this is something we usually cover in a more advanced course with ArchiCAD. For this case, you might be interested in maybe the base parameters, which would be the ID and category, especially the ID over here, and even so the structural function if you're planning to create analysis or calculate the structure for the project. You can always mess around with this option over here. So pretty much these are the main parameters we have for the beam. Don't forget that you can also mess around with the editing parameters. I already explained how you can create a hole with this option over here, but you also have the possibility to, for example, split a segment for the beam, left click, and if you notice, it's gonna be split over here. You can also, for example, left click, create a curved type of beam vertically, something really useful in the latest versions of ArchiCAD. You can also specify how you want your openings to behave, whether it's going to keep the proportion or maybe the distance. Okay, if you notice over here, the holes are positioned and now we have a curved type of beam. You also have the possibility to create a curve, which is completely vertical. So yeah, we pretty much have the same parameters as with all the tools. These three are for the horizontal shape. You can create a beam which is curved but on the horizontal plane. So as always, take as much time as you need, mess around with the different parameters for the beam, and in the next lesson we are going to put everything into practice to continue with the modeling of the example project. Alright, so having explained the beam tool, let's put everything to the practice before we continue with new concepts. How about we solve the columns? We need 6 columns over here on each of the sides of the footing, and also we need some tie beams between the different isolated footings. Okay, so let's focus on these 2 elements for now. Let's go to the ground floor. Now keep in mind we got the foundation level over here, but if you activate the ground floor, you still need to generate a reference. Okay, or even if you got the reference lines intersecting, you have a clear reference where the columns will be positioned. So either way, you can right click on the foundation level and show as a trace reference, or use the guidelines as a reference. Okay, let's go over here to the column settings. Let's activate the settings. Now the columns that we are going to position will start from the ground floor over here and will end on the level 3. So the height of the column is going to be 9 meters. Okay, and the section, well, later on when we cover a little bit on how we import standardized type of profiles. For now, let's keep the section as a general criteria, something that will measure maybe 40 by 40 meters. Okay, later on when we cover a specific topic, a new concept, we will switch back the columns into a real section or a real profile. But for now, let's start out with something volumetric. Let's set this to be 40 by 40 in the width and the depth. And then for the height, let's set this to be 9 meters. Okay, make sure that the top and the bottom stay horizontal and the reference axis of the core will stay on the center. Also keep in mind to be careful about these parameters. This is going to be the first parameter here, and completely vertical here. For the segment, make sure that you don't use multi-segments, keep it straight and simple. a single segment, 40 by 40, 9 meters in height, and everything else is looking decent and pretty good for now. Let's press OK, and let's simply go to the ground floor and left click over here, left click over here, and simply position all the columns we require for this experimental project. Okay, let's see how it behaves in 3D. And yeah, we pretty much have the columns already. Don't worry too much about the profile for now. This is something that we're going to go back in a little bit. Let's continue now with the tie beams. For the tie beams, if we go to the foundation floor, you will notice that we got a tie beam over here, one more here, another here, and another one over here. Yeah, if I remember well, so yeah, pretty much we'll have 4 types of tie beams, because this is the projection of the primary beam, if I remember well. Because if in the perspective you can visualize we got a tie beam here, here, and here. And the measurement for the tie beam, if I remember, it was 40 in height by 30 in width. And the length is basically connecting all the pilasters for the isolated footings. Okay, so let's go back to ArchiCAD. Let's go to the foundation level. Let's activate the beam tool. Let's set the height to be something as 40. Okay, point 40 over here, and the width we set it's going to be point 30. So let's set the width over here, 40 by 30. Well, it doesn't matter in which segment you, in which group of these options you set the width and height, because it's pretty much the same parameter. For the holes, well, the hole won't matter too much for now. This floor plan, everything's looking good. In the segment options, let's keep it single segment once again. And be careful over here, because for some reason I still have the tapered size active. Let's keep it uniform size for now and fixed type of length, just in case, okay? And for the beam settings, for the reference axis, for this case, for the experimental project and for more practical purposes, I'm going to keep the reference axis on the very top of the beam, centered on the beam on the top side. So having adjusted these parameters, let's press OK, and let's start drawing the first tie beam, which is going to come from this footing over here until this point. Now, for some reason, the length is fixed. Let's go back to segment. Let's see if we can change the length to be flexible length, because my guess is that if we activate the fixed length and we input the value over here, you can set this to be maybe 6 meters. And when you start drawing your beam, it's going to be completely fixed. Okay, this is a nice small parameter to keep in mind. But if we switch this to be completely flexible, you can left click and specify the length graphically. So I don't know, maybe this can come up handy if you plan on using standardized length for your beams. Okay, but for this case, to keep it practical, let's keep it as a percentage. Press OK. Let's go ahead once again and draw the tie beam here. From the left part of the footing to the right part of the footing. Okay, let's draw the next tie beam here, from the bottom to the top of the pilaster, and let's select this tie beam. Let's create a copy over here, and let's create an extra copy over here. And in 3D, let's make sure that everything is set correctly. So yeah, it's looking quite decent for now. So yeah, pretty much it's ready, and we can say that now we have finished the columns and the tie beams for the project. So take a minute, take as much time as you need, make sure to solve the columns and tie beams, and in the next lesson we will continue with the primary beams, which will be positioned in between the columns, and of course we will solve also the secondary beams, just in a preliminary and volumetric manner. Alright, so for the primary and secondary beams, this is going to be quite simple. Let's just see if we got some measurements for the primary beams. If I remember well, it was also a standardized type of profile, which is in one of the cut sections. If you notice, the width for the beam or the profile is going to be 0.40 and 6 millimeters by a height of 41 centimeters. Okay, with 3 millimeters over there. So this is something else that we're going to adjust once we get into how we can use standardized measurements. But for now, what I'm going to do is for the primary beams, I'm just going to keep it a rectangular shape, something basic, which is going to measure 40 by 41. Okay, let's keep it simple for now, volumetric. And for the secondary beams, right over here, actually on the ground floor, you can visualize the code for each of the beams that we're going to use later on. But for the secondary beams, how about we go with something else? Over here, we can measure this 0.25 by, let's make it 25 in height by 20 in width. So let's keep it simple for now, volumetric. We will adjust it later on. Let's go to the ground floor, okay, deactivate the trace and reference. And once again, let's activate the beam tool, okay? We said in height it's going to be something as 41, and in width, let's make it 40 for now, even a little bit less, to my guessing. Just keep it volumetric, simple for now. Later on, we will worry about adjusting the beam. For the holes, floor plan, and beam, so everything is looking decent. And let's keep the length also flexible. Let's press OK, and let's simply go ahead and start connecting the different columns. Let's left click over here to position one of the beams, starting off from over here up until this point, okay? Now, if you have a clear definition of materials with priorities and pretty much everything that we covered in this course, but in the first sections of this course, you can always, for example, take the beam and connect it to the center. But for this case, for modeling purposes, I'm going to keep it on the edge of the column, okay? Let's create a copy of this beam over here. Let's also create a new beam, which is going to be vertical, starting from one of the edges of the column and connecting up until to the other, and connecting to the other edge. Let's select this beam and let's create a few copies over here, one over here and one over here. I'm going to select once again these two beams and create an extra copy over here. So let's go to the 3D view, see how it behaves. It's looking quite good for now. Okay, just for volumetric purposes, preliminary purposes, it's looking quite decent. Okay, now to make the management a lot easier in ArchiCAD, my recommendation here is to select the beams that we have modeled so far and simply group them. You can press Ctrl G to group everything. So if you select one of the beams, it will select the whole group, or you can select everything, edit, grouping, and the group command over here. Now just keep in mind that you also need to deactivate the suspend group command. So if this one stays active, it's still going to select everything as a single element. But if you deactivate the suspend group, it's going to unpause the grouping function and will select everything. Now, in order to position and adjust the height a little bit better, my recommendation here would be, how about we go to the ground floor and we create a cut section view just for modeling and working purposes, okay? So let's go to the section tool over here. Let's left click over here, left click, and create a cut section view. And let's proceed and open up this cut section view. So in this case, you can clearly see the heights for your structure. For this case, yeah, the beam is working quite fine within the height limits. It's looking quite decent for now. So yeah, let's go ahead. Let's select the whole group. Ctrl C to copy everything. Let's switch to level 1 and Ctrl V to paste the different structures we got over here. Keep in mind, you need to position the mouse outside the marquee or the preview marquee and press enter in order to complete the copy and paste function. Okay, now don't forget that you have also another possibility. If you right click on the ground floor, you can always use the edit elements by stories. And over here you can, for example, select all your beams, specify which type of action you want to do, whether it's going to be a copy, cut, or delete action, from which story you want to copy your elements, up until which levels you want to copy them. So this is a little bit faster. Instead of the Ctrl-C and Ctrl-V commands, you can also check out this window over here. But since we got just a few elements, I'm going to proceed. Level 2, Ctrl-V, Enter, and finish up the primary beams for my structure. Alright, so let's proceed now with the secondary beams. Now, if we go to the ground floor, you will notice that we also have a specific type of profile, something we're going to adjust in a little bit. But for this case, let's model this once again as a volumetric entity, which is going to measure somewhere around, let's make it 25 in height by 20 in depth, something like this, okay? And also keep in mind we got 1, 2, 3, and 4 beams, okay, which is going to be faced on the shortest span as per usual, or in this case we can use this type of direction. Oh, I did a small mistake over here, something I'm going to adjust in a little bit. I thought that the separation was 6 by 6, but if we notice over here, it was actually 6 by 5. So pretty much the shortest span over here is going to be faced on the vertical direction. So this is the direction that we're going to position the secondary beams. Using the opportunity I have with this mistake, which would be the easiest way to adjust the whole structure. And this is an amazing trick we have within ArchiCAD. If you create a marquee around the part of the structure you want to displace, let's say in this case I want to displace everything 1 meter. You can create a marquee of the elements you want to adjust, and then go over here, edit. We can go to the reshape command or the reshape group over here, and you can simply activate the stretch command. We can move this 1 meter over here, and if you notice, ArchiCAD will automatically adjust the structure, adjust the elements, except these two commands we got over here. We need to move this manually. Also, a good idea over here would be to maybe activate the suspend group, and even so maybe ungroup the elements, edit grouping and ungroup. Let's see, we can try once again to maybe adjust everything, create a marquee over here, edit, reshape, and use the stretch command. Let's move this 1 meter over here, and there we have it. If you notice, it has directly adjusted the length of the primary beams. Instead of measuring 6 meters, now they measure 5 meters. So this is quite a nice mistake to have, because I can also explain this amazing trick with ArchiCAD. But if you notice, yeah, it has adjusted the columns, so we also need to repeat the same process with the other types of beams. For this case, what I'm going to do is maybe I'll select everything, simply delete this, move this footing 1 meter over here, and move this element also 1 meter over here, and adjust this element 1 meter, okay? Also click on the reference line, 1 minus, and it's going to adjust automatically for you, okay? Once again, 1 minus, and we adjust the structure. So for this case, we clearly now have the shortest span, which is going to be 5 meters over here, and the longest span is going to measure 6 meters, okay? So having adjusted the structure, now let's proceed with the secondary beams. And the easiest way to solve this would be to simply select one of the primary beams, press Ctrl U to activate the multiply command, okay? And for this case, what we can do is simply distribute the different beams, activate the -1 beam or the -1 parameter over here, so it doesn't create a beam positioned on the reference line here. And how about we create somewhere around, let's see how many copies we need. We need 1, 2, 3, and 4 copies. So let's go back to ArchiCAD, set this to be 4 copies, press OK. Let's see if this works out. And yeah, there we have it. So you can pretty much use a multiply command to create a few extra beams over here. And once you create the extra beams, select them, group them with Ctrl G, or edit and grouping, and group over here, okay? And now we simply need to go to the settings dialog, adjust the measurement for the secondary beam, which is going to be 25 by 20, okay? Don't worry too much about the length, this is something we also can adjust. Press OK. Okay, so it's looking quite good for now. Okay, and now let's select everything and use the extend or adjust command. Let's activate the command, press on the reference line over here, and there you have it. In easy steps, we have created the secondary beam. Let's once again repeat this process. Select all the secondary beams, activate the adjust command, and adjust everything to the center line of the primary beam. So in 3D, it's looking quite good. The position is good. And let's use the cut section view, which we positioned earlier, which was this cut section over here. Let's open up the section to visualize a little bit better the secondary beams. And yeah, it's pretty much done. So the only thing we have to do now is make sure to copy the primary beams and secondary beams to the next levels. But before, how about we make sure to also copy the secondary beams to the other quadrant over here. There we have it. Let's once again select all the primary beams, make sure to group them so everything behaves in a grouped manner. We can simply go to the 3D view. And now what we have to do is copy the primary and secondary beams to the next stories. Now, a small thing to keep in mind is that later on, when we start covering the different constructive systems in each of the quadrants, one of the constructive systems is going to be prefabricated elements over here. So it's not necessary to input the secondary beams here. We also have the hollow block and beam constructive system here. So yeah, secondary beams don't apply, neither over here and nor over here. So in this case, how about we maybe copy the beams and simply delete the secondary beams for the 4 quadrants we got over here. So let's right click the ground floor, edit elements by stories. We are going to copy the beam element starting from the first level. Over here, the action is going to be set to copy, and we are going to copy everything to the second and third level. Let's press OK. Okay, so everything's looking good. And now let's select the secondary beams over here, and on all of these quadrants here, and simply delete them because they are not necessary later on. And now we can say that pretty much we are done with the base structure we require for this experimental project. Keep in mind that later on in the upcoming lessons we will adjust once again the structure, but for now just make sure to model out the primary beams, make sure to finish up the secondary beams, and also if you have the structure to be 6 by 6, make sure to adjust the separation instead of 6, adjust it to 5 meters. Don't forget, the easiest way is to use this nice trick within ArchiCAD. Simply activate the marquee tool, select that part you want to stretch, edit, reshape, and the stretch command will do everything for you. Alright, so far we have solved the base structure we require for the project. Now it's time to evolve it and set the generic profiles into something a little bit more standardized, into something a little bit more real. And for this case, what I'm going to do is I'll use the codes in my own region, which is in Mexico. But if, let's say, you're from Europe, if you are from North America, if you are from South America, feel free to use any type of profile and any type of code that is within your standardized profiles within your region. What you are going to do is, in this case, let's navigate to the menu bar. You'll find the options tab over here, and in complex profiles, you can see we got the import standard steel profile option over here, which is an amazing window because right over here, we will start with the country code. First things first, you need to specify from which country you're working on. where is the project based. So let's say if you're from Germany, you can find the code over here. If you're from China, you also got Chinese type of standardized profiles, and there's just different countries you can specify. Well, in my case, since I'm in Mexico, I'm going to use the Mexican code from the Mexican standards for the steel profiles, and then you can specify also which type of geometry you are looking for. So you get the I and H shapes, C, U, L, rectangular or circular, both of which are hollow. Now this is an interesting point to comment later on, a small tip that I'm going to share, but feel free to find for any type of code you might want to use. For example, in the Eurocode, we also got extra shapes such as T, L, C, I, Z shape, a little bit more separated. But the codes will be different for each of the countries. So for this case, make sure to set this. And now what you can do is visualize this graphic. You will notice we got the G2 measurement, G1, G3, and G4, which are the different parts for this type of profile. And pretty much all the measurements will be displayed in columns over here. So you got the G1, which would be the height for the profile. You got the G2, which is the width for the profile, and then the different thicknesses for the different parts of the profile. Okay? For this case, I'm going to set this to be exactly the same as I set it on the example. I'm going to import the OR 406 type of profile, the IR 406, the IE 254, and extra profiles that we can find. Okay, so for this case, since let's start off with the first type of profile, which is a rectangular shape for the column. Let's find this in geometry. I'm going to switch to the rectangular hollow, and what you can do is simply navigate and find the code or the standardized type of profile you require for the project, which would be in this case 9.5. okay, this one over here. Once you locate the code you want to use, you simply need to activate this button, add profile to this project. Okay, now it's really important that you also keep an eye out for the assigned building material. This is something that you need to specify which type of material you are going to use with these types of standardized profiles. Now moving on, let's for example import the IR 406 type of profile. For this case, I'm going to switch to the I and H type of shapes. And let's see, we got the IR. I'm just going to navigate a little bit over here, which was 406 by 74.4. This one over here. Let's also add this one to the project. And let's go to the next one, which would be IE 254. Let's try to find for this one once again 254 by 37.8, which is this one over here. Okay, now I'm pretty sure that we also have extra profiles for the roof, if I'm not mistaken. Let's see if we got something else. And yes, we have the profile we are going to use for the purlin. That's the word for this type of beams, the horizontal purlins that are beneath the metal sheet for the roofing. So in this case, we are going to import a C type of profile, which is CE76 by 6. So let's go back to ArchiCAD and let's navigate to that C shape. And let's find the profile, which was 76 by 6.10, the first one. Add this to the profile and we're ready to go. So what you can do is simply find the profiles. Once you have imported them, specify the materials and simply press the import button. So what's basically going to happen is once you import the standardized profiles, it's going to add the list or the specific profiles into your profile manager list. So you can, for example, open up the profile manager and you will notice now that in this list, we have the standardized profiles going on over here. We got the IR, the IE, we got the OR, and of course we got the CE. Okay, so Feel free to add as many standardized types of profiles you require for your project. Don't forget, import standard steel profile, and you can navigate pretty much any type of country you require for your project. Alright, so having imported the different profiles, let's simply go ahead, select the columns, and what we are going to do is simply use the standardized profile. And the fastest way to do so is over here. Simply click on this icon, set it to be the complex profile, and then go ahead and specify it to be the one which we just imported, which is OR 406 for the Mexican code, of course. In this case, yeah, it's going to be, if I'm not mistaken, it's just going to be a little bit less than we had originally. We even saw a little bit more. This is something that we're going to adjust anyway, so no worries about that. So yeah, the columns are pretty much set. Now, there's a nice thing I want to comment over here, a nice little trick. If you, for example, intersect both of these beams, you will notice that the hollow column is still completely hollow and the beams are still completely generated. So, let's say for some case you want to work your profiles with the reference lines intersecting between them. And for some reason you also want your hollow column to completely remove the inner part of the beam. So ArchiCAD automatically cuts it away. How can you do so? Okay, so first off, let's go to the Profile Manager, Complex Profiles, Profile Manager, and let's navigate and select the OR type of profile. Let's hit the Edit button over here. Now, if you notice over here, we got some nice line thickness going on over here. Let's simply first off, right click and deactivate the true line weight. And in second place, if you notice over here, the complex profile is basically just this outer part. We don't have anything going on in the inner part. And there's a really nice trick that you can apply over here, because you can pretty much create a filling which is completely invisible. So just take the fill tool and make sure you set this to be the air material, airspace. This one is really amazing because it's completely invisible, but you can use it specially to automatically cut away the inner intersecting elements, okay? And once you have created the airspace material over here, it's still a hollow type of column, but in digital manners, now it's not completely hollow. Let's go ahead, press the save button, and let's go back to the 3D view. So if you notice over here, it's still not going to delete the inner part for the beams. And this is happening because the steel that the beams have as the building material has more priority than the inner air. What we have to do for this case is also go to the building materials, element attributes, building materials over here, and make sure that the air material, let's search for the air, is set to the maximum. So in this manner, we can still keep in quotation marks a hollow type of column, but with the air material, when we press OK, what's going to happen is that you can now intersect the beams with the reference line, and ArchiCAD will also delete the inner part for your intersection, which is quite an amazing trick that we can always apply. And of course, whether you want to work this as an intersecting element, or if you, let's say for example, you want to adjust the beam over here, this will depend on how you want to work, which one is more comfortable for you, and also if you are considering to model the project for structural analysis, this is something that you should comment with your structural engineer. So there are two ways on how you can work this. The first one is simply model everything to the border of the column, and the second one, if you are planning to intersect this, you can do so and then create an inner filling of air for your columns. Alright, so having commented the small nice trick we got for the columns, let's continue now with the adaptation of the rest of the structure, okay? So first things first, we need to select all the primary beams, and let's go ahead and simply switch them to the complex profile over here, and then set this to be, if I remember well, IR 406 in my case, okay? So pretty much, as you can see, the beams are completely set. Now we have to be, if you want to solve this as fast as possible, because if I remember well, we have a really small intersection going on over here. If I zoom in just a little tiny bit, you'll notice that now the beam is not being connected, or even so it intersects just a little bit with the column. So what you can do is apply the trick that we already mentioned. Maybe, for example, select all your beams and make sure that they intersect. Maybe intersect this one and this one. So we got a T-type of intersection. But in reality, since we create the hollow material, not sure what's going on over here because it's not intersecting these elements anymore. It should subtract the elements directly, okay? In my case, what I'm going to do is I'm simply going to adjust all the beams manually. So before we jump into the final adjustments, how about we also select the secondary beams over here and set them at once to something as the IE254. Now let's go to the sections. Don't forget to also adjust them in the vertical displacement, because in this case what we have to do is select the beams and make sure that they stay beneath the reference line. And for the secondary beams, we also can select all the secondary beams over here and simply adjust them in the vertical displacement to set them to be right on the reference line for the level 1. So what I'm going to do now is, how about maybe we even delete these primary beams over here, and I'm going to take maybe 1 minute, maybe 2 minutes, and I'll simply adjust manually all the different beams so they match exactly on the border of the column. And pretty much we're set. If you can notice, it's quite easy to adjust the beams, and now we have a completely real type of section or profile going on in our project, especially for the beams, for the columns, for the footing, and everything else. Well, of course, in the construction project, we usually have a small space, so the beam can be welded or connected with extra elements. It's going to connect to the column. But in this case, for the digital purposes of the beam project, we can still make it to the border. But this decision is finally up to you. You can decide how you want to model everything. And as always, take as much time as you want. Make sure to check out the different options, how you want to adjust the beams, how you can start working a project, a structural project in ArchiCAD. And having said this, we can now put an end to the first part of this section. So we have now completed the first part for our project, focusing on structural modeling using the column and beam tools, along with the integration of objects into our project. As you have seen, there are numerous possibilities when combining these tools, but after covering the key concepts, you should now have the essentials to model various types of structures. For the next module, we will move on to reviewing concepts related to the simulation of constructive systems through the combination of several tools and techniques. Don't forget to take a break before starting the next session, and without further ado, I'll see you in the next module.